Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we are beginning our project of building an equal weight S&P 500 index fund. All right, and so starting off, I'm here in Google Colab, and we're going to begin our project by making an API call. So join me at this link, colab.research.google.com, where you can code along. First things first, we are going to make an API call. Now, for that, we're going to make a variable called API URL, and I'm going to put in here a string of our API. We're going to be using a sandbox API known as iexapis.com. All right, and so here we can access sandbox APIs, which means that the data will be randomly generated, and as well it will be free because many APIs, they cost money to use, but sandbox, this will be a free API. All right, so after this URL, we're passing in /stable/stock because we want the stable stock data. And we're going to pass in here a symbol. So I'm actually going to pass this in as a variable, and therefore I need to put an F at the beginning of my string, which means this will now be a formatted string, which means I can put in variables as long as they're in curly brackets. Now my symbol, this can be any stock I want. For example, I could do Goog for Google stock, or alphabet stock to be exact. All right, so this is going to give us the stock data for alphabet stock, and it's going to get it from this sandbox API. Next up, if we want to actually use IEX APIs, we have to create an account there. So make sure you go to the link of iexcloud.io and create a free account and select the free plan so you don't have to pay anything. And then you can go to your tokens and you can find the test token just by going to your account and then going into the tokens there. You'll have a secret token and a publishable token, and if you toggle on the sandbox feature, then you'll be able to see your sandbox tokens. So these sandbox tokens means that you won't be charged when you use the API if you're using a sandbox token. All right, so I'm going to show you my sandbox token in action. So I am going to go to /token equals, and then I'm going to put in here my IEX Cloud API token. All right, so that is going to be a variable that I'll have to create. All right, and I have gone into my account and turned on sandbox mode. Therefore, I can access my sandbox tokens, which are free, and they also have no charge, so they're free, yes, and they will allow you to generate random data. That's why they're a sandbox token. If you're using a real token to make a real API calls, you would have to pay, so I'm showing you the free version. All right, so here, this is my publishable token for sandbox only. So if you want to create your own tokens, then just create an account at iexapis.com to get your own tokens. All right, and next up, we can put this API URL to use. So for that, I'm going to use the requests module. All right, requests is going to allow me to create an HTTP request in Python. So I can make web requests. So I do have to import requests. Let's just import that at the top of the code cell here. I have to import that module if I want to access its functions. So I am going to use the get function to get my API URL. This means that I'm going to make a request to this website, sandbox.iexapis.com. And this is going to return for me some data, which I can convert to JSON format with this function JSON. The result is going to be my data that I've gotten from this API. Then I can print out data and we'll see our results. So let's run this code cell and just give it a minute because the first code cell always has to initialize. And look at this. Now we get this message that we have our symbol, which we selected, Goog. That is the stock symbol or token. Then we have the company name and a lot more information about this. So we can also just print out data itself without the print function because we're in Colab. Because we're in a Jupyter Notebook, we can get information like this. So look at that. We have a lot of information about this alphabet stock. Note that this is just randomized information because we're using a sandbox API, but if you were paying for the API calls, then you would get real information. All right, but it's always best to practice and learn on a sandbox API because it'll be completely free and it still follows the same process. Okay, and just like that, we've been able to create an API call. Next, we will have to parse our API call because look at this, we got a lot of information passed back. And I might not need all of this information. I might only need some of the different values. For example, I might only need one of these columns and none of the rest, but I can put all these to use. All right, so next up, what we're going to do is we're going to take our data and we're going to put it into a data frame, specifically a Pandas data frame. A data frame is like the Python version of a spreadsheet, so it can store a table. And coming up next, we are going to get the important columns that we need instead of working with all of these because that would be way too overwhelming. So join me in the next lecture where we will take our stock data that we just loaded in and we're going to convert it to a format that will be a lot easier to work with, known as a Pandas data frame. Hello everyone and welcome back to our course. In the previous lecture, we learned how to make an API call, and in this lecture, we are continuing our project. This time, we're going to learn how we can use our API call and how we can get stock data about all of the stocks of the S&P 500 companies. So we're going to need to get the symbols for all those companies, and then we're going to have to use our API to actually get stock data about those companies. Then we're going to convert that data into a Pandas data frame. The Pandas data frame is like the Pandas version of a spreadsheet, and it's going to allow us to work with a data set or a spreadsheet or a table in a much more efficient manner. So very often you'll take your spreadsheets, you're going to convert them to a Pandas data frame. So let's create a new code cell and we will get started. First, we need a list of all of the companies that we want to analyze. All right, so I am going to import Pandas, the library, in order to be able to create Pandas data frames. Then I'm going to use the function read_html. So in order to get my list of S&P 500 companies, I'm actually going to go to this link here. Just make sure it's in a string, this Wikipedia link. And this is the Wikipedia page that has a list of the S&P 500 companies. We can see here there's this table of them. And what I'm interested in is just this symbol column, which has the symbols of all of the companies, because then I can take these symbols and I can feed them to my API to get information about each symbol, which represents each company. The result of this is going to be reading that HTML page, so I can store the results of this in a page variable. And then if I want to get the page content, I can print out page, right? Then I'll run this code cell and look at this. The result that we have is several tables. We have this first table, then we have this second table. And that corresponds to this first table, S&P 500 component stocks. Then if you scroll all the way down, once you get past all of the 500 stocks in this table, you get the second table called selected changes to the list of S&P 500 companies. If you scroll all the way down, you'll see that that is the second table and there's no more tables. So when I read this HTML file, I get those two tables as a result. Now I just want the first table, which is my stocks table. So I'm going to make here stocks table by getting the page at index 0. So that is going to return for me just this first table. And I can prove that by, let's do this in a different code cell. And then I'm going to create that stocks table variable. And then I'm going to print out stocks table. And look at that. We get that first table only, which has the symbol of the company the name of the company, more information about it in 9 different columns. All right, great. So now we have this stocks table. We can also get more information from it. Like, for example, we could do stockstable.info, run this code cell, and we can see here what we have is a Pandas data frame. So we took that web page and we found any tables on it and we converted it to a data frame thanks to that read HTML function. Next up, what I want to do is take my table and I now want to feed all of its information to my API. So I want to take all of these symbols and feed them to my API. So I'm going to create another code cell here, and I am going to loop through for every symbol in my stocks table at the column symbol. Because we can see here, we have our stocks table, and we can see that it has a column symbol. It has a column security, SEC filings, etc. 8 or 9 different columns. We are interested in the symbol column because that's what we're going to feed to our API. All right, so for every single symbol, I am going to create a new API URL variable, and I'm going to format a string. So I am going to go back up to where we made that call to our API earlier in the previous lecture. Here we go. We have this link. You can see we have this formatted string. So I'm just going to copy that exactly because we're doing the exact same thing. We're just passing in a symbol to our sandbox API with our test token. So I'm just going to copy that whole line because we're using the exact same API. All right, then I'll paste that in. Just make sure you have an indent. All right, and there we go. That's going to make an API call for every single stock symbol. Now, how do we actually get the results? Well, we can use the requests module. The requests module is what we used earlier. You see here, we're just going to do the exact same thing where we get the results that are stored in API URL. So let's just do that same thing. We'll make a requests variable. And we're going to, well, not a request variable, rather, we're using the request module and we're using its get function. We're going to get the API URL results and convert it to the JSON data format. The result we can store in a variable called data. Then I am going to create a stocks data frame variable. And I'm going to assign it to equal stocks data frame.append. And I'm going to append to it every single result for my stocks. All right, so I'm just going to declare stocks data frame outside of the loop. That way we have it being continuously updated. To create a data frame, I use the Pandas library, and I'm going to use its data frame class to create a new data frame object. And I'm going to pass in a columns argument, which refers to the number of columns that you want to have in your data frame. All right, so what are the columns that we want to have? Okay, well, we can define any number of columns that we want. Let's make a variable we can call stocks columns. All right, then I'm going to just create that stocks columns, and I'm going to choose a ticker column, a price column, a market capitalization column, and shares to buy column. Okay, great. So now we've instantiated that stocks data frame variable. And then for every single stock, we're going to append a new pandas.series. And we're going to pass in the symbol as well as the data at the latest price column, followed by the data at the market cap column. And these are 2 columns that we can get, which we've seen previously. We saw all the different columns that we can get from our sandbox API. And we're just selecting a couple of them here because there are quite a few that we could use. All right, so we have the symbol, latest price, and our market capitalization. Shares to buy, we can pass in not available for now. And as well, after that array, we can then pass in an index, and our index is going to be the stocks columns. Then we can also pass whether or not we want to ignore the index, and we can say true. All right, so this is going to append to our stocks data frame every single stock in that list, right? So then I'm going to just exit that for loop at the very end, and we can print out our results. The results will be inside of our stocks data frame, right? So I can print out that just by passing it to the print function. Then I'm going to run that code cell and we will get our results. To recap, we created a stocks data frame variable to store all of our stocks. Then we made an API call to all of the S&P 500 companies and to get stock information about them. And we stored that information inside of that stocks data frame. Now just give it a moment to complete because it is going through 500 different stocks. So give it a few minutes to create the data frame. Okay, and after a minute, we get our results here. We can see here we have our stocks data frame. We have our ticker, which is the stock symbol. Ticker is another word for a stock symbol. Then we have the price, the market capitalization, and shares to buy, which we have as not available for each one currently. All right, next up, we're going to learn how we can create batch API calls. So this is going to allow us to make the API calls much faster. Join me in the next lecture where we will continue our project. Hello everyone, and welcome back to our course. In the previous lecture, we learned how we can make an API call for all of the S&P 500 companies. Next up, we're going to learn how we can make the API call faster, how we can improve performance, because often you'll find that the slowest part of your project is going to be actually making that API call, making that HTTP request. And for that reason, you can find your program running slow. For example, it took us a minute to get all of these results. We're going to learn how we can get faster results, make our script faster by making batch API calls. So instead of making the API call for all of these at once, we're going to actually batch them. And often API providers will even give you a discount if you do this. So that's another benefit to doing that. All right, so let's jump back into our project and we will make a new code cell. All right, first we have to take our symbols and we're going to split them to 100 symbols per request instead of doing all 500 at once. So for that, I'm going to create a list and I am going to make a split list function out of my stocks that I have. So I have my stocks data frame and I'm going to take that stocks data frame, or rather not the stocks data frame, but let's see, which one was it? It was the first page that we got. Yes, our stocks table. Okay, yes, we want to take that stocks table and we want to split that. All right, so I'm going to take my stocks table at only the symbol column. And at that column, I am going to split it into 100 per table. So we're just taking our big table and we're splitting it. Now, we do have to make this function split list. So let me define a function split list. We're going to take in some list and we're going to take in our number per group, which is 100. And what I'm going to do is loop through for every index in a range of 0 up to the length of my list, and as well my number per group. I am going to yield my list at the index up to the index plus number per group. So this is an efficient way of taking a list and splitting it. All right, the result of this is going to be my symbol stock symbols groups. All right, and next I want to now take these values. We can actually see what we get. I can print them out just by passing that and running this code cell. And look at this. Now we have this table, and it's actually multiple tables, so 100 companies each. You can see here. So our list of companies has been split into 1, 2, 3, 4, 5 different tables. Great. All right. Next up, I am going to create a string that contains all of my symbols. So for that, I'm going to make a new code cell. And I am going to loop for every index in a range of 0 up to the length of my stock symbols groups. So I'm going to go through each of my tables and I'm going to make a stock symbols strings list. So let me just declare that outside of the for loop, this stock symbols strings initially, it is going to be an empty list. But then for every single element, I am going to call the append function. I'm going to append it with a comma, and I'm going to join my stock symbols groups at the current index. And I can also print out the results to show you what each of those is. So I'll print out stock symbols strings at the current index. And if I run this code cell, look at that. We just get all of our stocks separated by a comma. We can also print out the results at the very end. We can just print that, and we'll see that we have this list format. And the list just contains this string. All right, next up, I want to use my batched lists in order to make my API call. So let's make another code cell, and we're going to loop for every, let's say for every symbol string inside of our stock symbols strings. Next, we're going to make the API call. Now for the API call, we're actually going to be using a different URL this time. So let me make here batch API call URL. We're going to make a formatted string, and we're still going to be using sandbox.iexapis.com/stable/stock/market, but this time we're going to be using the batch link. So because we're making a batch API call this time. Instead of making 500 single API calls for every single stock, we're batching them into groups of 100, which is often the max. And so therefore, we're actually reducing our number of API calls from 500 to 5, which is quite an improvement. To do that, we have to use batch. Then we're going to pass in types equals quote, and symbols equals our value here, which was our symbol string. Right? I'm going to pass in here symbol string. All right, and then I'm going to have to pass in my token as well. So I'm going to append here my sandbox token. EX Cloud API token. That's my constant that stores the token. All right, and that is going to allow us to make a batch API call. So make sure you're using this new link. Otherwise, you won't be able to make a batch API call. You'll get an error if you try to use the non-batch link. All right, that's going to be the URL that we're going to use. Next up, we're going to follow a similar process. We're going to use requests to get a response at the batch API call URL, and then we're going to convert it to JSON data. We're going to take the response of the request and convert it to JSON. The result will be a data variable. And we can already print out the results of data to see what we get. I'm going to run this code cell, and look at that. Look how much faster our results are. Okay? We have here all of our symbols, and we can scroll to the right to see information about those. Okay, and next up, let's loop through for every symbol inside of our symbol string dot split at every comma. Okay, because I'm just going to show you, if I remove these and I just print out the symbol string, you can see what each symbol string is. Okay, we have here 5 different symbol strings, and I can print out a line break between each to show you. Here we go. We have these 5 different symbol strings, and so that's why we want to loop through every symbol in them. So when I split at a comma, that's actually going to split every single word, and it will remove the commas, and it will return an array that I can loop through. So let me show you. I can then print out every symbol here. I'm going to rerun the code cell, and look at that. Now we have every symbol. All right, and what I'm going to do here at every symbol is I'm going to create a data frame, and I'm going to append to it my results. This is similar to what we did earlier. If I scroll up, you can see before we created this data frame, our stocks data frame right here, and we defined its columns as well. And we're going to do the same thing. All right, so let's just create stocks data frame again. In fact, I could just use it, but I'm just going to recreate it. Okay, here, just before the for loop, I am going to create my stocks data frame variable again. So I'm going to create a new Pandas data frame. And in fact, I can call this batch stocks data frame just to differentiate it between the previous one. Okay, and what I'm going to do is create this data frame with those stocks columns. And then I'm going to take my batch stocks data frame. I'm going to assign it to equal itself, but appended with a new pandas.series. I'm going to pass in here first my symbol in an array here, followed by my data at the symbol, at the quote, and at the latest price. So note that this is slightly different to what we did earlier. Previously, when we didn't do any batch calls, we were just able to get data at latest price. But this time, because our data is actually a batch, we have to go into the symbol and then at the quote and then at the latest price. So take note of that difference. As well, I want to take the data at my symbol and at the quote, I want to then get my market cap. So I'm putting in values into columns in my data frame. Then the number of shares to buy is not available for now. We're going to actually calculate that in the next lecture. All right, as well, exactly as we did previously, we're going to pass in an index. Our index is going to be our stocks columns. And then we're going to pass in whether we want to ignore the index, which we can set to true in this case. Okay, that is going to append to our data frame our stock data for every single stock. Then at the very end, I can print out my data frame and I can show you my results. Okay, let me rerun this code cell and note that the results took a lot faster. Look at that. Instead of taking a minute, it took only a few seconds, and that's because we're batching our API calls. And look at this, now we have all of our stocks, the price, the market capitalization, and the shares to buy. Awesome, and that is how we can get a lot faster performance thanks to our batch API calls. All right, next up, we are going to learn how we can calculate the number of shares that we should buy of each stock based on the value of our portfolio and the performance of the stock. All right, so join me in the next lecture where we will work on that. Hello, everyone, and welcome back to our course. Previously, we learned how we can make batch API calls to get information about stocks. And in this lecture, we're going to fill in this column shares to buy because currently we set them all to not available. But in this lecture, we're going to learn how we can calculate how many shares we should buy of each stock. All right, so let's create a new code cell and we'll get started. Right, and we're going to get started here by first getting the value of our portfolio. So we can actually allow the user to put in their portfolio value by using the input function, which prompts us to get user input. I'll put in here, enter your portfolio value. Right now, if I run this code cell, you'll see here, I'll be prompted to enter a value like 3. Okay, and I can actually store this result as portfolio value. That will take whatever the user puts in and store it in portfolio value. And I can prove that just by testing this out, hitting run and entering some value, like let's say I put in 100, hit enter, and I'll get printed out 100. Okay, now we do have to do some validation though, because we want to make sure that strings are not allowed, that only numbers are allowed. So what I'm going to do is I'm going to use a try statement, and I'm going to try to convert my portfolio value to a float. So I'm going to store this as portfolio value float, and I'm going to attempt to convert the value to a float. Now, if portfolio value is not a number, then I'm going to get what's known as a value error. And then I can print out not a number. And I can prompt the user to enter their portfolio value again. So this time, if I hit run and I enter some value like 10 as a string, I'll get the message not a number, and I'll have to re-put it in as a number, an integer or a float or a decimal. Okay, great. Next up, now that we have actually gotten the value of our user's portfolio, let's put that to use. So I'll make another code cell here. I am going to take portfolio value float, and I'm going to work with that. So what I'm going to do is just take portfolio value and convert it to a float. Then I'm going to divide that by the length of my batch data frame, which is called batch stocks data frame. And I'm going to get its index. The result is going to be my position size. And I can print out the result that we will get from that equation. I'll hit run. Okay, the result we get is 0.02 if I round, because my portfolio value was 10. And we can also print out here, let's print out the batch stocks data frame index. So the index was range index starting at 0, stopping at 505, and a step of 1. And I can also print out the length of that, and I'll just do it in a different line here. This way we'll analyze all of the values part of our equation. The length was 505, so we're just taking the float of our portfolio value, which is going to be 10, and we're dividing that by 505. The result is 0.02. All right, and next up, I'm going to loop for every index in a range of 0 up to the length of my batch stocks data frame at the ticker column minus 1. So I'm going to loop through all of my stocks, and I'm going to take my data frame, and I'm going to use the log function, location function, and the index at number of shares to buy, which we had previously. Let's see. We had previously this column. I'm just going to look for it. Number of shares. Okay, here we have shares to buy. Yes, so make sure you put in shares to buy here as your column name. So at that column, we're going to use math.floor, and we are going to take our position size and divide it by our price. So I'm going to take position size divided by our data frame at the price column and at this current index, because we need to go through each of the indices. All right, so that is going to populate this column shares to buy with this result of our position size divided by the price. Then we can print out our results after the for loop. Let's print out our batch stocks data frame. And okay, let's see. We just have to import the math library. Yes, okay. If we want to use the Python math module, which has functions like floor, we do have to import it. So just import math in the code cell. And then look at this. We have now in our data frame, we have our shares to buy. And here we can see that they have been rounded to integers, so that's why we get 0 for a lot of them. We can also just call batch stocks data frame without the print, and we will see the same information just formatted differently. All right, and if we want to get larger values, we just have to increase our portfolio value. So let's say we had a much larger portfolio value. Hit enter, then rerun that second code cell below that, and you'll see here, look at that. Now your shares to buy are a lot larger because you have more money to work with. If you only have $10 to work with, then you have a lot fewer shares that you can buy. All right, whereas if you have more money, then you can buy more shares. All right, and that is how we can calculate how many shares we can buy for every single stock. Next up, we are going to continue our project, and we're going to learn how we can create an Excel file out of our results. So we can take our Pandas data frame and put it into an Excel file, which is going to be easy for us to share and to work with. The Pandas data frame is still very important to use because it's much faster and it has these useful functions, but then often you want to have some result like an Excel file. So we're going to learn how we can take our results, our data frame, and how we can put it into an Excel file. So join me in the next lecture where we will work on that. Hello everyone, and welcome back to our course. To finish up our project, we're going to learn how we can take our recommended trades here and how we can convert this data frame into an Excel file. For that, we're going to be using the Excel SX Writer library, which allows us to create formatted Excel files. All right, so for that, we're going to continue in our same project. I'm going to create a new code cell, and I'm going to import right away the Excel SX Writer library. This will allow us to create our Excel file. All right, then I'm going to grab Pandas. So I'm going to use pandas.excelwriter to begin, because I'm going to take a data frame, a Pandas data frame, and convert it to Excel. First, I'm going to pass in the name of my file. I'm going to call this my stocks.xlsx, which is the Excel file type. Then the engine is going to be Excel SX Writer. So that engine is what we imported. Then Excel Writer, that is a function or a class of Pandas. So we're creating a new Excel Writer. The result is going to be a writer. And to be more clear, we can call this Excel Writer. All right, then I'm going to take my data frame, which was batch stocks data frame, and I'm going to convert it to Excel. So I can take this Pandas table and convert it to an Excel spreadsheet. For that, I'm going to use the function toExcel, and I'm going to pass in here several arguments. First, my Excel writer, then my sheet name. My sheet name is going to be my stocks to buy, or I can call this, let's see, S&P 500 stocks. All right. And then I'm going to set whether or not I want the index. We don't really need the index. We can set that to false. All right. So we have these three arguments, and that is going to convert our data frame into Excel. All right. And just like that, we're going to have our result. To save the Excel file, we're going to call our Excel writer.save. Now, as well, for Excel SX Writer, you do have to install it first, because a lot of different modules like Pandas, they're pre-installed in Google Colab, but Excel SX Writer is actually not pre-installed. So make sure you add this pip install Excel SX Writer. So here, that's ensuring that we're going to install it before we import it. And then we can run this code cell. And look at this, we're collecting the writer. So first we're downloading it, and that is that first line pip install Excel SX Writer. Then we're going to call that function, and we're going to save the file. Now, if we go to this folder icon, look at that. We now have this file that's been created, stocks.xlsx. We can click on these ellipses, these three dots. We can download, rename, delete the file, copy the path, or refresh. And that's because all of our data as part of the project is going to be in stocks.xlsx. Then you can hit download to save the file to your computer. I'm going to save that, and then you can open it up in Excel or Google Sheets or any program that can open an Excel file. For example, here I have opened the file in Google Sheets, and look at that. I can see all of my columns from the Pandas data frame, but now they have been just put into an Excel file. Awesome, and that is how we can build out an S&P 500 equal weight index fund. We have our S&P company symbols, we have the price of each stock, we have the market cap, and we have the number of shares to buy calculated with our portfolio value that we input. Congratulations everyone on building another project, and I'm excited to see you in another project. Hello everyone, and welcome to our project preview. In this project, we are going to build a quantitative momentum investing strategy. So we're going to learn how we can perform more algorithmic trading with Python and Pandas. First, we're going to learn how we can make an API call to actually get the S&P 500 companies and get stock information about them. Then we're going to execute batch API calls. So we're going to have quite an efficient and fast API call system. Then we're going to begin building out our strategy. So our first strategy is going to remove the low momentum stocks and only use the top 50 high momentum stocks. Then we're going to build a more nuanced strategy where we're going to find the high quality momentum stocks versus low quality momentum stocks. And we're going to calculate momentum percentiles in order to find the 50 best momentum stocks. So the ones with the highest high quality momentum score. Then using the top 50 high quality stocks, we are going to be able to calculate the number of shares we should buy per stock with our portfolio value. And in the end, we'll be able to take this data frame that you see here and convert it to an Excel file for easy access. So we're going to have each stock of the top 50 of the S&P 500. Our top 50 is going to be calculated first via just the ones with the highest momentum and then with the highest quality momentum. So the best of the best. We're going to have the price of the stock, which we've scraped from the API, the number of shares we can buy based on our portfolio value. We'll have price returns for different time intervals, which we scraped via the API. Then we'll calculate return percentiles for every time interval as well. And finally, we'll have the high quality momentum score for each stock. We're going to use an average of all of the percentiles to give each stock a score. And the one with the highest score is the one that is the top of our list to invest in. So that is going to be our project. We're going to learn how we can build an investing strategy using quantitative momentum. It's quite a fun project with a very interesting strategy for investment. I'm excited to teach you how to build out this project and this type of strategy. So join me coming up in that section. Hello everyone and welcome back to our course. In this lecture, we are going to begin our project of building a quantitative momentum investing strategy. So here I am at Google Colab at colab.research.google.com, where I will get started building my project. Our first step is going to be to make an API call. All right, so we are going to make an API call in order to actually get information about stocks. So what are my stocks going to be? Well, my stocks, I'm going to get them from Wikipedia. So for that, I am going to use Wikipedia to grab a list of all of the S&P 500 companies and get their stock tickers or symbols. And then I'm going to pass those to my API to actually get information about every single company. So first, let's make a new code cell and we're going to import the Pandas module. This is a very useful module for performing a lot of data science. For example, we're going to use the read HTML, this function, in order to get tables from an HTML, which can be an HTML web page. So here I'm pasting in the link to a Wikipedia page called List of S&P 500 Companies. I can show you this by just following the link. Here it is. This is a Wikipedia page and it has two tables. It has S&P 500 component stocks and also has selected changes to the list of S&P 500 companies. So whenever we call read HTML from Pandas, we're actually looking for any tables on the page because Pandas is for working with data. So we can get these two tables with that read HTML function. The result is going to be my tables. Okay, and I can prove that to you by printing out tables. I'm going to run this code cell and you will see the results. Just give it a minute the first time you run the code cell, or a few seconds. Okay, there we go. Look at this. We have two tables. Our first table has the stock information, and the second company has the changes to the stocks. All right, now we only want that first table because really we just need the symbols. We want the symbols of the top 500 or the S&P 500 companies because these are the companies that we are going to feed to our API to get information about them. So how do we get those top 500? How do we get those companies? Well, all we have to do is call tables at index 0, and that's going to give us just that first table. I'm going to call it stocks table. Then if I print out the variable that I have now, stocks table, I am going to see that I have just that first table now. Awesome. Okay, and we can also verify the type of the table just by calling info, and you will see that the table is actually a Pandas data frame. A data frame is very similar to a spreadsheet or a table or an Excel file, but it's just a Pandas type, which means it is open to a lot more data science and a lot more functions. So it's very, very commonly used. Okay, great. So now we have a table of all of our stocks, as well as a lot of information about them. We have their symbol, their security, their headquarters location, the year they were founded, and more. All right, so we really are only interested in the first column, which is that symbols column, because that's what we have to pass to our API. So we're going to loop through our symbols column and pass that to our API. So for this, I'm going to loop through for every symbol in my stocks table at the column symbol. So I'm going through this one column only, and I'm going through every single row. And I can show you, I can print out the symbol, and you'll see that we'll get every single symbol. Look at that. We have the symbol of the 500 S&P companies. All right, and instead of just printing out the symbol, I want to actually take that symbol and feed it to an API. The API is going to allow us to get information about that stock. All right, so for that, I can do a whole bunch of the calls at once. I can just show you one example initially. Okay, let me start with just one example. All right, so I'm going to choose one symbol. For example, we could do Goog or Alphabet stock. This is the ticker for Alphabet stock. Then I am going to create an API URL. This is going to be a formatted string, which means that I can have a string with variables inside. And this is going to be a link to my API, which in my case is going to be a sandbox API, meaning it's just for practice. It's not actual data, because if you want to use an actual API, then you'll have to pay for every call. But if you use a sandbox API, then you can practice for free. So the API we're using is IEX APIs. And you can either pay for calls, or you can use a sandbox to get free calls to the API. But the sandbox is going to just return dummy data because it's free. Okay, I definitely recommend using the sandbox when you're just learning. Then we're going to use stable/stock, and we're going to pass in our symbol. Then we're going to get stats from that API, and we do have to pass in a token. So this token is going to be your sandbox token. We can store it in IEX Cloud API token. So what you have to do is create an account at iexapis.com, and if you enable the sandbox on your account, then you'll have a test token. So this will be a sandbox token, which means you won't be charged for using the token. If you don't enable sandbox and you use a real token, then your account will be charged. But you can create a free account with no charges at all if you use the sandbox token, which is what I'm using. So I'm going to have to create a reference to my sandbox token. So let's create that variable. I'm just going to create it here. It's called IEX Cloud API token. And I'm just going to copy my test token because I created an account at iexapis.com. All right, and that is going to make a call to the API at that symbol. Then I can call requests to actually make a request of that API URL. Now, if we want to use requests, we do have to import that module. This allows you to make an HTTP request. What you do is you use the get function and you pass in a URL. So I'm requesting to get a URL. The result is going to be a response, and the response is going to contain data from that URL. Because we're using an API, it's actually going to return very specific data. It's going to return data about that stock. And I can convert this to JSON by using a JSON function. And that means I'm going to convert the data to a JSON format. And I'm going to store the results in data. And then I can print out the results by printing out data. And look at this. We have the company name, Alphabet Inc. Then we have its market cap. It's week 52 high, week 52 low, etc. Now we can also see those with line breaks just by printing data itself without the print function. And look at this. Here we have all of the pieces of information that we can get from that exact link, from that API. And we can see here we can get average 10 column, next earnings rate, year one change percent, day 200 moving average, and more. We won't need to use all of these for our portfolio, but they're all available for us. All right, and this API call has quite a few pieces of information, and we can just get values from it by calling a key. So you can see this is a dictionary where the key is the name of the property and the value is the value of that property. For example, if I take my data at my year one change percent at that column, so 1 year's return, then I hit run. Look at this, I get 0.52 as my year one change percent. So that's how I can access any of the values. Awesome. Okay, now that we know how we can make an API call, next up, we are going to execute batch API calls in order to get not just one stock, not just Alphabet stock, but actually all of the S&P 500 companies. So join me in the next lecture where we will make that batch API call to get all of the stocks that we need. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to make an API call to get information about a stock. In this lecture, we're going to learn how we can make batch API calls to get data about not just one stock, but actually about all 500 stocks in the S&P 500. All right, so for this, let's continue on in our project and let's create a new code cell. Our first step is going to be to take all of the symbols inside of our stocks. So we can see here we have this symbol column, and we want to take that column and we want to split it into groups of 100. So that way, instead of having to make 500 individual calls for every single company, we are going to do only 5 calls to the API. And that's going to really improve performance because often HTTP requests and API calls are some of the things that will slow down your application the most. So we can reduce the time it takes us to get data and also reduce the cost by grouping our API calls. All right, so we are going to need to put to use this stocks table, and at this symbol column, we are going to get all of them and group them into groups of 100. All right, so I'm going to use the list function to create a list. I'm going to create a new function, a custom function called split list. All right, and I am going to take my stocks table, which if we search for it, we can see that that is exactly the table that holds all the stocks. There it is. Okay, so we are going to take that stocks table and we only need it at the column of symbol. Then we're going to pass in 100 as the number of stocks per group. Okay, so let's create this custom function now. The list function, that's a Python function, but split list, that is a function I'm going to define as a custom function. We're going to first pass in the list, and then we'll pass in the number per group. All right, so then we're going to loop for every index in a range from 0 up to the length of the list, as well as the number per group. And I am going to yield the list from the index up to the index plus number per group. The result of this is actually going to be symbol or stock symbols groups. And I can also print for you that variable so you can see exactly what it will contain. I'll run this code cell and look at this. Now we have 1, 2, 3, 4, 5 different, or 6 even, because we have a few at the end. Okay, so we have 6 different groups here of 100 different stocks each. Well, the first 5 have 100, but then the last one, it just has the 4 leftovers. All right, so just like that, we've been able to group our stock symbols. Okay, and next up, we are then going to create an array. I'm just going to make a new code cell here. I'm going to create an array, otherwise known as a list, and I'm going to call this stock symbols strings. And I'm going to make this list, I'm going to loop for every index in a range of 0 up to the length of my stock symbols groups. That is that variable that we just created. And for every single group, I'm going to take my stock symbols strings and I'm going to append a comma followed by the stock symbols groups at the current index. Okay, then I can print for you the results of each of these. So I'm going to just print out, well, I can print out my stock symbol strings at the end. Then I'll hit run and look at this. We have this huge list of all of the strings and I can print for you at every loop to show you how it increases over time. Okay, so first we have the first 100, then we have the second 100, then we have the third 100, then we have the fourth 100, then we have the fifth 100, then we have the last 4. So we are just taking all of our values and we're putting them into a list of lists. All right, great. And that is now going to store all of our stock symbols grouped. Now that we have them grouped, we can perform a batch API call. So instead of performing 500 different API calls, we're going to perform only 5 because we have 5 different groups. Typically 100 is the maximum. That's why we chose 100 as our value here as the number of stocks per group. And in fact, I can make that a constant number of stocks per group. That way we won't have any magic numbers. Instead, all of our numbers will be defined. All right, and great. Now let's actually make the API call. So I'm going to create a new code cell. I'm going to loop for every symbol string inside of my stock symbols strings. Okay, and let me just print out for you the symbol string so you know what we're actually dealing with. I'm going to run this code cell and look at this. We have every single symbol string is a list of all of these symbols in that group. All right, and so what I want to do at every single group is create a batch API call URL with a formatted string. And this time I'm going to pass in a batch API call. So note that this URL is actually going to be different from when you make one API call to one stock, because now we're making still one API call, but to multiple stocks at once. So I'm going to use https sandbox.iexapis.com/stable/stock/market/batch this time, because I'm making a batch API call. And I'm going to pass in here types. The types, I want to get stats and quote, because I'm getting my properties from stats and also quote, and you'll see what properties we need shortly. Then I'm also going to pass in the symbols, and I'm going to pass in the variable in curly brackets. The symbol is the symbol string. And finally, we also need to add to this formatted string our token, because if we want to make an API call, we have to pass in our account token. I'm using this sandbox token, so it's just going to be free, but it's going to return dummy data. And I stored that in my constant IEX Cloud API token. Awesome, and that is the URL for the batch API call. Now, we're going to follow a very similar process to the previous lecture where we call requests, and we are getting some data from a site. The URL is that batch API call URL, and we're appending the JSON function to convert it to JSON data, so then we can store the result in a data variable. Then I want to loop for every symbol inside of my symbol string dot split at the comma, because you can see the symbol string, it's that list of all of these symbols in this group. So if we call the split function, that means we're splitting it at every comma, and we're going to return a list of all of the strings without the commas. So we're taking this one string and we're turning it into an array or a list. That way we can loop through every symbol in this string. And what I'm going to do is I'm going to create a stocks data frame I can also just call it data frame for short, but stocks data frame is more descriptive. Okay, and I'm going to use the append function to append a new entry into my stocks data frame at every single stock. So the stocks data frame, I actually do have to initialize it above the for loop. Otherwise, it will be recreated at each loop. So make sure you initialize it. It's going to be a pandas.dataframe. So we're creating a data frame object, and we're going to pass in a columns argument here. And I'm going to pass in here stock columns. The columns are what columns we want in our data frame. So let's define stock columns. For stock columns, I am going to pass in here a list of all the columns I want. I want a ticker column, which is the symbol. I want a price of the stock. For this project, I also want 1 year price return. So that is how much of a return the stock had in the previous year, and shares to buy. So we're going to calculate how many shares we should buy later on in this project. All right, so then we can append to the data frame a row for every stock. So how do I append that? Well, I'm going to use a pandas.series object. I'm going to pass in here the symbol, which is the ticker. Then I'm going to grab my data, which is my JSON response. And at the symbol, at the quote, I am going to get the latest price. That's going to fill in that price column. And note, that is from the quote column. Then I also want to fill in my next column. The next column is 1 year price return. So how do I get 1 year price return from my result? Well, I can get data at symbol at the stats, and I can get it at the year one change percent column. So to make this more clear, I can actually print out for you our data at the current symbol. Okay, so let me just print that out. I'll just temporarily remove that one line and rerun this code cell. And look at this. We can see the data at every single symbol. This means we can see all the data that we can work with for every symbol. And this is actually the equivalent of what we had previously, where we saw all the different columns right here. We can see here all the different columns we have to work with. Okay, this time not only are we working with stats though, we're also working with quote, because we got the types of stats and quote. So there are actually different types of data you can return. We want stats and quote. All right, so that's how I know that we have to get the data at the symbol at quote and the data at the symbol at stats, because that's where we can find the latest price and the year one change percent to fill in those columns. You can also just print out the data itself. So for that, just go outside of the for loop and print out data, and you'll see the response converted to data. You'll also just have to remove this for loop, otherwise it will get confused, the compiler. So just print out data. Okay, and then you can see here, you can visualize the data that you get. The data is going to be in these 5 groups because we made 5 API calls. Or perhaps 6 because we had a last group that had 4. Okay, yes, we have 6 because we have 5 with 100 each, and then the last one just had the leftovers. So that's the data that we can get. All right, so then we can put back in our loop. We're looping through every symbol, and we are going to add its latest price and its year one change percent to our data frame. That way we'll have a row for every single company. Now we still have to fill in shares to buy. Currently we don't know the shares to buy because that's actually determined based on our portfolio. So I'm just going to pass in not available, but later on in this project, we're actually going to calculate that. Okay, as well, I'm going to pass in an index here for my series. The index is going to be the stock columns. And as well, I can pass in whether I want to ignore the index. We can actually just ignore the index. Then we can print out the results, which will be inside of stock's data frame. So I'll rerun the code cell. And just give it a few seconds and look at that. It has returned our data frame. Now, because we batched the API calls, we got the results in just a few seconds. If you made the calls one by one for every single stock, you would still get the same results, but it would just take a few minutes instead to actually get the API results. And also it would be more expensive because you're doing 500 different API calls if you don't group them. All right, we can also just make a new code cell and type stocks data frame, and we'll get the same content just in a slightly different format. We can see we have the ticker name, the company name, the price of each company's stock, the 1 year price return, and shares to buy, which we'll fill in later. Awesome, and that is how we can execute a batch API call. Coming up next, we're going to begin building out our investing strategy. The first step of our investing strategy is going to be to remove the low momentum stocks, because we are going to find the stocks with the highest momentum in this project, and that is going to determine which stocks we should buy. So join me in the next lecture where we will continue our project and we'll jump into learning how we can start to implement our investment strategy.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.